directional antenna. This is a data cable.
This is the charger cable.
This is the manual. Then let me introduce this host to you. This is the power switch of the main unit. Then long press the power switch. It will turn on. After turning on, our default is it defaults to a full screen detection mode. And then below the default is a shift to switch modes. Shift to switch mode. This is the full Bose. This full screen detection mode. This English. This light will light up. Then press this switch again to GSM signal is a detection band of 900 to 1800. A detection band. Then switch it again. When this light is on, it's a detection. Mainly for Wi-Fi, which is very useful, which is very common for us. The world also has a unified standard. There are 14 channels, and 13 of them are available. The 14th channel is a test platform. Then press this mode again. Is a strong magnetic detection mode. It mainly detects strong magnets in the locator. Even a dormant locator can be detected, but some dormant locators have magnetism. Then there is a mode below. This mode is a headphone jack. When you plug in headphones, when plugging in the signal output, the light will light up. Then long press the mode button. It will turn on the mute mode. In the mute mode, the light below will light up. Then we adjust the sensitivity level here. The key below adjusts the sensitivity level. Press the high sensitivity. Press the low sensitivity. At that time, when we detect that it is a full screen mode, the antenna symbol will light up. When the antenna symbol starts, we connect this antenna. What band is this antenna in full screen mode? Its frequency range ranges from 50 megahertz to 8 gigahertz. Then we connect this antenna. Then if this antenna mode is pressed, change to another mode. This is also a GSM mode, but our antenna is also here. Comes in from this place. The signal comes in from this way. We connect this antenna. Then press it again. The antenna mode shows the antenna is here. Then we connect the antenna to this place. This antenna is ours. The signal collected by this antenna is Wi-Fi, 2400 to 2500 MHz. This band of frequencies. Then we install the antenna. This one, I have two antennas. It can be installed. These two antennas can be exchanged. Now, let's switch to the first full screen mode. The frequency of this antenna the frequency of this antenna is 900 to 1800. Then, when we install the antenna, it mainly collects signals. This antenna collects signals from 900 to 1800, of course. We can also install this, and this antenna mode is a directional antenna, but it can be used as a 50 megabyte. Its bandwidth is 50 megabytes to 12 gigabytes, but our reception range is 52.8 gigahertz, but all the signals in the market, we can basically receive all of them, just receive them. Then we install it at this time. Generally, if you use this mode, install this antenna is okay. You can also use this antenna can be changed according to your needs, can be replaced. Big Brother, when we first started the signal of his phone, because there are many signal sources here and mixed signals, then we just turned on the mute mode, long press the mute mode, and it will be turned on. There is a speaker mode, but this speaker, there are two speakers inside. One of the speakers is digitally processed. So the sound it emits is processed digitally. The sound of our data conversion, its sound mode, its sound remains unchanged. Because of one speaker. Our speaker has not been digitally processed. What's the effect of not being digitally processed? It is what it comes in as no good. It will emit the same sound as the signal we read. So you can hear different sounds through the speaker. Because of different locate takubajingai locator 70 new. It includes jamming device. The signal it receives. The waveforms are different. The sound it makes when it comes out is different. We can use this sound to distinguish these electronic products. communication electronics. Then this place is introduced here. Then we start over again. Let me introduce charging problem.
Let's solve the charging problem first.
For the charging issue, charge it here. This is a Type-C charging port, and there is a red light here. If you charge it, the red light will light up, and the green light means full. Then take a charger. For charging, the USB is also plugged in. Pay attention to the direction. This USB has a directional problem. Then this thing is plugged in with direction. Plug it in like this to charge. It will light red when charging, and it's green when full.
Then if we want to detect this locator,
the commonly used locator, using a GSM antenna. GSM antenna is also installed. Now we are detecting. If we bring a locator here, we can detect it. This locator, we mainly detect the locators. We can't control the signal it receives because it receives satellite signals. We can't control it. We mainly detect.
The transmission of these wireless communication devices,
a data packet during transmission.
The receiving signal, we just is difficult to detect. We use transmission technology. It's transmission to detect by transmitting signals. Then when I turn on the locator, after it's turned on,
it will send out signals
to detect the locator. We have a second mode, which can also be detected. But the main thing is that we have this specifically for GPS detection. This one is ringing. It has a signal. It's a 900 MHz locator.
because the signal is intermittent.
When the signal is intermittent, so our signal reception is also intermittent. Sometimes it has a periodic signal transmission. So we also know that the main characteristics of this locator.
Of course, this locator also has a strong magnet.
We turn off the locator now, and through the strong magnet mode, we can also detect the locator. This strong magnetic mode, then we use the strong magnet. The strong magnetic mode.
It will also detect the locator.
If you sleep with a locator and it has a magnet, if it has a magnet, it will also detect.
You see, it doesn't need to be turned on.
When we detect eavesdropping and tope, it can detect for eavesdropping and filming.
We usually use the full screen mode. 2.4G, because the so-called 4%.
All eavesdropping and surreptitious photography.
They mainly steal.
If it's for peeping, it's video transmission. Video transmission is done through Wi-Fi. And the cost is low, and the transmission is fast. We use it. Now we use it. If it's a Wi-Fi channel, we use this antenna, because this antenna is mainly designed for 2.4G. Its frequency is so fast that it can,
it will be better on the 2.4G channel.
This is a Yagi antenna. It's 4 girls every day. Then our office has Wi-Fi, and there may be someone receiving this phone. Yes, there is a data exchange on the phone. There is a data packet exchange. Then we can adjust the low sensitivity can be adjusted to high. Then we look at it. It's the 8th channel. The 8th channel has a product wireless device which is connected to Wi-Fi. It has data exchange. It's the 8th channel. The 8th channel is ringing. Then different channels, different signals. For us, we can't analyze how many things there are. If there are many things, they all go through different channels. Then they must be different. Under different channels, nothing is displayed. Then we detect the interference source. If we detect the interference source, and the interference source, we mainly use full channel detection. Comprehensive detection. Diagonal interference. We have a comprehensive detection. We use this directional antenna to detect. It's easy to distinguish. The distance we detect is generally 1.5 to 2 meters.
Because if the detection range is too large,
we will be affected. It will affect our judgment.
We can't find it accurately.
To find these things, if the search range is just right, within 2 meters, we can look for it within this 2 meter range. If it's a locator, we can adjust the detection range. We can adjust the sensitivity by adjusting the back to dorm to about 0.5 meters. Then if we detect a common tracker, as I just mentioned, there are three modes. We can detect in full screen mode or through a dedicated channel to detect the locator, because the locators used in the market are for G cards. But the main channel is still to GSM models. If the GSM signal is used, it's distribution. It can be used worldwide. And the cost of making a locator is also very low. Then we use the third mode. We use the strong magnetic mode to detect it. That's all for the main point. There is another one that is through software. We use the data cable through the data cable. When we plug in the data cable, it automatically switches to full screen mode. When we install the antenna, I'm using a GSM antenna to install it. The antenna of the locator and install it to the full. It's installed. We are all people. It's in the full screen mode by default. But if we don't press it, it's also in the national mode. The national mode, then we can download it through our mobile phones. This mode is, why is there this light? This mode is mainly to detect wireless sleeping locators. Some locators are always dormant. We can download a software through our phones. Download it. Where is the software? Scan it through QQ.
Scan this QR code to scan it.
Scan the QR code and it will be downloaded. Scan it to CQQ. Oh, there is no QQ. There is no QQ, but I've already downloaded it. It's downloaded. Open this software. This app PC. The app transmits the signal to the phone's headphone jack. Plug it in and it will show. The detector shows. Once inserted, we turn on the intensity mode. Strength mode. This is the power mode. Let's quit and start over. Exit and start over. If there is a locator signal, the locator signal, its signal strength will be different. It's not equal to distance. According to the distance of the locator, near and far, it will show different waveforms. The height of the waveform, the trough and peak of its waveform, its intensity is different. Then the signal here may be strong. The mobile phone signal is relatively strong. Its waveform will be higher. But the locator generally has when it has its own transmitting signal data package, has its own pattern, it usually has 2 waves. No, now, before the locator had 3 peaks, 3 points, then it will drop down. And then drops to the bottom, then it goes down. And then there are 3 to 3 peaks. Now the locator transmits data faster and faster. It usually generates 1 or 2 peaks, and then it must be a broken wave peak and valley. It must follow this rule. Generally, the locator, if you don't move it, generally the locator transmits data transmission. That's probably the case. Then I can check the data. Here is to view data. When did it send the signal? How long it sent signals? And how far it has traveled? It's displayed here. It also shows. Okay, thank you all.